negative 2 from the right. It's negative 1/2 times negative 2 plus 1. Negative 1/2 times negative 2 is positive 1. 1 plus 1 is 2. Everybody see? Yeah, like I said, there were a few that were wrong. And I didn't point it out because I figured it was an arithmetic mistake. Does anybody not see that I messed up? Okay, and then for this one, what's it going to be?
2.
Yeah, since these two are the same, it is 2. If they weren't the same, now does it matter? Wait a minute. Does it matter that neither one of these are or equal to? No, because again, it does not matter if there's a hole there or not. Even if there's a hole at that particular point, it can still have a limit. What? It's still going towards 2. Okay. Now we're going to review some trig, some log stuff, just all sorts of good things. Woohoo, calculus, right? Yeah. Do a calculus dance. Okay, so for the first one, we are learning how to solve these algebraically, which just means we're plugging in what x is approaching. So this is the natural log of e over 2 times e. Now, does anybody know what the natural log of e is?
I mean, I can listen.
We can figure it out, right? In case you don't remember, because that was the part that we didn't get to last year, is if you have a log, that's the same thing, a log base e is the same thing as the natural log. That's what a natural log is. It's a log with the base of e. So if you have a log with the base of e, they kind of, yeah, it's like you would have, if you did the circle method here, you'd have e to the y equals e. So yeah, there's a little 1 here. It's an understood 1. So the natural log of e is just 1. That's how we get that. But from now on, you can just know that. And then there is your answer. 1 over 2e. Now, when we're plugging in the 5 from the left-hand side, is there anything special we have to do?
No.
No. The only time we have to do something special is if it gives us a weird answer. If it gives us like something undefined or something weird like that, then we have to worry about if it's left or right. So we just plug in 5. I got 20. Joy! Oh, I love it! Oh, joy! We got some trig. Yes. I mean, it's good to know that we didn't spend a semester in vain, right? Yeah. We had a reason for it. Okay, so we're going to plug in pi. So it's sine squared pi, which just means the sine of pi squared. Remember that? It's just, we write it. We just write it like the one above it because it takes less work. Mathematicians are inherently lazy. plus 2 cosine of pi. How do you find the sine and the cosine of pi?
The unit circle.
Woo! Unit circle, yeah.
Only we had one.
We drew one earlier. Here it is. Oh, I even have it highlighted here because evidently we were using pi before.
Yep.
So, which one is sine?
Y.
Yes, the y coordinate. So 0, and then cosine would be the x coordinate, and that's -1. So that would be 0 squared plus 2 times -1. -2. Stop that. There's no yawning in calculus.
Can we not plug that into the calculator?
If this was a calculator problem, chances are this would not be a calculator
So will
problem.
we get a unit square? Not unit square, unit circle.
No, but you can draw one.
Oh, joy.
Yes. You can.
I mean, you can, but it'd be easier.
Oh, easy.
Yeah.
Yeah, that goes with calculus.
Uh-huh. But like, what if you like one of those like middle ones? Like, beautiful unit circle ones, and it was like crazy numbers. You got a unit circle last year.
Yes,
Oh, I
that's
might still have it then. Can I use
true.
that?
You can use it to study.
Dang. I keep calling it unit square right now.
Okay, 5 pi over 3. So I'm so adding another page here. Maybe. There it goes. So 5 pi over 3. We are going to go with probably this is not a calculator problem. 5 pi over 3, we would multiply by 180 over pi to get it into degrees, so it's something we're more used to seeing. The pi's will cancel. 3 will go into 180 how many times? 60. And what's 5 times 60? 300. Good. So when I draw, 300 is going to go over here somewhere. Reference triangle. So what's this angle going to be? 60. So this is a 30, 60, 90 triangle. Across from the 30 is 1. Across from the 60 is square root of, yep, and it's negative because it's going down. Now, very good. Now this was tangent. So tangent TOA is opposite over adjacent.
Joy.
So that would be what's opposite? 60. Sorry? Negative square root of 3. Yeah, I just couldn't hear you. Over 1. So it's negative square root of 3. So on top, I have negative square root of 3. On bottom, I have 25 pi squared over 9, because I squared it. Change flip. Negative square root of 3 over 1 times 9 over 25 pi squared. Negative 9 square root of 3 over 25 keep forgetting to
You
put
keep
the
trying to
sign.
think too high.
I know. Square.
That's a gorgeous number.
I thought so. There it is.
I mean, at least it's on the
Now my notes doesn't show the negative, so I'm gonna go back and make sure. I probably messed up on the notes, but I just want to make sure.